This video is on 4.2, try it number 3. I'm going to walk you through it. We did it in class, so this is real specific to the 140 class, but you can, whoever's watching this, hope you find it beneficial. First thing I wanted to do is talk about the distance formula and how that comes actually from the Pythagorean theorem. So Pythagorean theorem says c squared equals a squared plus b squared, and if we wanted to solve for the hypotenuse, we would have c equals square root of a squared plus b squared. And I hope you notice here how that relates. So d in this particular problem is going to be what we're trying to find, our hypotenuse. So the distance between any 2 points on a linear graph is going to be d. And we have this square root, and the distance between the x values is our a squared. The distance between our y values is our b squared. So when we're given 2 points, for example, if I had the point 3, 5, and I had 7, 10, and I wanted to find out what the distance between those 2 points were, then I would plug them into my formula here. So I'm going to use the distance formula. Now I could just use the Pythagorean theorem. I could just figure out what's the difference in my x's and pop it in there, right? That's really what I'm doing. So x values, I would have 7 minus 3, or again, I could just write 4 in there, that's fine. And then 10 minus the 5. It's just like kind of doing your slope, right? And that all squared. And again, I could just pop a 5 in there if I wanted to. Instead, I don't have to write it out like this. So this would end up being d equals square root of 4 squared plus 5 squared. And then calculate that out. And we would get 16 plus 25. And so we're going to get d equals the square root of 41. That's a prime. So let's actually, because it's a word problem, we're going to want to calculate that out. And so hit that toggle switch on your calculator if you have the multi-view or something that's just always giving you radical 41, then you want to make sure you hit that double arrow by your enter or whatever key you might have. 6.40, we're just going to go to 2 places here. So that would be the distance between those 2 points, and that kind of makes sense if you were to graph that. Let's do that. Actually, let's just quick graph. If I had 1, 2, 3, 5, I'm just really sketching here. And then I had, let's see, 4, 5, and then up to 10. Like up here, this distance here would be about 6.4 in whatever units we have. We don't really have units here, so I would just say units. In our word problem, we're going to be looking at miles. So having a fractional piece is fine. Someone asked about significant digits that you use in science. Sometimes we do that for science applications. For this one, because it's miles, we'll probably just even round to the nearest mile, or maybe even, like a quarter mile or something like that. I think that's what I did, or half. It comes out to the half, yeah. So that's how they did it in the answer book. They just went out 2 places. So I hope that helps. I'm going to save this page just as an example, and then I'm going to erase it all to do the word problem. Okay, so now let's get into our problem. There is a straight road leading from the town of Timpson to Ashburn, 60 miles east and 12 miles north. So east, I'm going this way, 60 miles, and then it's up about 12 north. So it's right about there. Partway down the road, it junctions with a second road perpendicular to the first. So I'm going to just draw a line here. I'm going to make this bigger down below, but just we're kind of tracking. Okay, so we have this starting point at Timpson. We are going to Ashburn, which is, this is 60 east and 12 north is how I know to get that point, and that's Ashburn. But partway down the road, it doesn't really say how far, so we know it might be, I'm just going to say an arbitrary, like right there. There's a second road that's perpendicular to the first, leading to the town of Garrison. So we know it's going to go down to Garrison, and it says Garrison is 22 miles directly east of Timpson. So we can kind of sit this here if this is like say 10, 20, 30, 40, 50, 60, kind of just judging my scale. Again, we'll rewrite it down below. So Garrison's going to sit maybe like right about here, and that would be Garrison. And we're just kind of penciling that in, and that is perpendicular to this line. So actually I want to get rid of that black line. So that's going to be right here. So going out like that. So we have a perpendicular line going acrossways. What we want to find now is how far the road junction is from Timpson. So we want to know this distance here. So we are going to need to use our Pythagorean theorem on that. We're going to have to figure out the distance. Using the distance formula, we can figure out the distance between these 2 points. Okay, and we are going to be able to do that by following some steps. If we know this point, we can plug it into here, and if we call this point the start, which is the origin, then we're pretty good to go. So we can just plug that point in here, or both points really, but this x sub 1, y sub 1 is going to be 0, 0. But how do we get to that point is the question. So that's what I'm going to map it out just a little bit better down below here with a straight edge. So I'm going to pause the video and make that happen here a little bit and get that set up. But meanwhile, I want you to try drawing a diagram of your own, a little bit more elaborate, having your coordinate system and your scale and things like that. So it looks a little more elaborate than what I have there, but not too fancy. And then you're going to try to write an equation to represent the line of Timpson to Ashburn. So if we can get this red line here from T all the way up to A, if we get the slope on that, we know the y-intercept, then we can find the equation of the line that's perpendicular, because we know about slopes of perpendicular lines, and we can get that equation. If we have that equation, we have a point, because we know this is 22, 0 at that x-intercept right here at Garrison. So we're in business, and once we get an equation and we have a point, we can find this value up here, which is the junction. That's what we want to know. Okay, so I've got my x and y axes set up there, and now I'm going to put my tick marks in a little bit. So I'm going to have I think I did like 10, 20, 30, 40, 50 to 60. Okay. And then I would have on the y-axis, I would have about 10 and 20. So now I know that Timpson is right here at the origin. So I'm going to label that T, and that's the point 0, 0. Just keep in mind. And then I have my 60 east and 12. This tick mark's probably a bit off. 12 would probably be right about here. So I'm going to say plot that point of Ashburn right about here. And that is the point 60, 12. Okay, so it's the way this is laid out. It's going to be, this is east, or miles east from the origin of Timpson, and this is number of miles north. So we do want to track that. So again, this is east and this is north, is how that's set up. So we can take our straight edge and we can connect. It's a little tricky for me on the surface, but here we go. And then we're going to go ahead and make that connect. So that's our line that we have to find the first equation for. So we're going to go ahead and find that line. And then we have, and we're going to call that T of X. Then we have the line perpendicular from this road here, or whatever, yeah, it's a road, that goes to Garrison. Now Garrison, it says, sits right about at 22, so that's probably right about here. And we're going to call that G, and that is, I'm going to say 22, 0. Put that point in, and it's going to be a little hard for me to get exactly perpendicular, but it's not going to look perfect. And then, so I'm going to put like a little perpendicular line through there. So it doesn't really kind of go straight. Maybe it should go more straight up and down. No, it's more tilted. Yeah. I wonder if I can get the end to go on here. Well, it's still a little off. There. This is a tiny bit tilted, so I'm just trying to line up where that would be parallel. Not very much, but just a teensy. So I'll mark that in there. And then this is the junction that we're interested in. So it's a tiny bit to the left of this 22. So it's not at 22. The X value is not going to be at 22, but it's going to be real close. And we can tell by the answer that this length will kind of tell us where that X is. But how do we get there? So we're trying to find, ultimately, if we can find this point of the junction, this is our goal, to find D. And we're going to plug this point, whatever that may be, into here. And it's not, the X is not going to be at 22, it's going to be close to it. I feel like I should just make that look a little better. Okay, so I'm going to get this ruler put away. So we have this information. So I'm going to have you pause the video and try to make that equation of a line if you have not done that yet. For step 2, we're going to use the points 0, 0 and 60, 12, and we're going to get the slope. So we're just going to go ahead and subtract those two, and we would get 12 over 60 equals 1/5. So our equation for Timpson, that line Timpson to Ashburn, T of X is going to be 1/5 X. You can call it whatever you want. We just want to kind of be consistent. Then 3, we're going to get that equation of from T of X to Garrison, that perpendicular line in the red there. So G of X will be minus 5x plus b. We have to find b. Remember, the perpendicular line is going to have a opposite reciprocal. So if we plug in the 22 there, we would end up with G of X will equal negative 5 times 22 plus b. So that'll give us, or sorry, I should say 0 there, because that's 0, that point, 22, 0. And we would get 110 is b. So this equation here for G of X is going to be minus 5x plus 110. Once we get that, then we have 2 equations. To find a point of intersection of them, we can actually just set them equal to each other. So we're going to set T of X equal to G of X, and that will give us 1/5 X equals negative 5x plus 110. When we solve that out, you will get X equals 21.15. You can just round off to 2 places. But we actually have to plug that back into one of the functions, one or the other, to find the corresponding y. So I'm going to just plug it in to t because that's just a little bit easier. It's just shorter. The other one would get the exact same answer. We would get 4.23. So this is our east. That's our miles east. And this is our north. So that's what this point right here is going to be. It's 21.15, comma 4.23. And once we have that point, we can use our distance formula and just plug in the values. Our x sub 1 and y sub 1 are 0, so we can actually just go ahead and, oh, that got really big, plug in 21.15 squared plus 4.23 squared, and crunch those numbers, square them, add them together, and you end up getting d equals square root of 465.2154, and that will be approximately 21.57 miles, which is our answer there. So I hope you found that helpful and you learned some problem solving skills and how to make diagrams and piece things together. So thanks for watching. Have an awesome day.